we need to figure out what allows you to move around. The muscles involved, the bone structures involved, and so on. I don't want you to get bogged down in trying to learn bone names. That's for when you take anatomy and physiology. What we want to think about today is generally how the skeletal system is put together and how your muscular system, in particular your voluntary skeletal muscles, help that system and work with that system to let you move around. So with our skeletal system, we have to think about what it means to be a skeleton. First of all, why do you even have one? It's going to provide some support for you, right? It's certainly going to hold you up, give you attachment points for muscles, and we also look at it as being very protective. Think about your rib cage. If we cut you open, what would you find under your rib cage? Heart, lungs, vital organs, right? So your skeleton actually provides a great deal of protection of your internal organs. We have a couple of different types of skeletons that we see in animals. You have what we call an endoskeleton. So endo being inside, so that's your skeleton on the inside. We could have an exoskeleton when we look at bugs, arthropods, those kinds of animals. Exo is outside, so they have a hard casing on the outside of them. But we also have a third known as a hydroskeleton. So hydro is what? Water, right? So the hydroskeleton is actually a skeleton that is maintained by water pressure. So it's very, very different than what we're used to. This system allows the body to hold fluids under pressure and give structure and support. Now, these organisms, worms, corals, things like that, are certainly not under the same gravity demands and stress demands that you are with your body and your need for the skeletal system. But for these animals, it actually does act as a cushion. So it protects against shock to the system. It does give shape, most certainly. And it's going to provide some support for basic muscle function. We certainly are not looking at the complexity of your system in these organisms, such as our hydra here, but it does give them enough to maintain a three-dimensional body shape. These things are not flat. They do have structure and support to them. With our exoskeleton, these are our rigid external skeletons, typically made of chitin, and some in our mollusks will actually be made of calcium carbonate. So basic structures that are hardened by these other materials. When we look at exoskeletons, one of their big downfalls is that they actually have to be shed before the organism can grow. So that means for some period of time, these organisms are going to be without any protection, such as our crab here. So with our crab, this is actually the crab at the back side who's moving backwards out of his shell. And what's left is this hard exoskeleton that's going to remain. And it won't go to waste in the ocean. Something will certainly use it or eat it, and it gets broken down. But when our crab backs out all the way from his exoskeleton in order to grow, we have to look at this animal as being very, very vulnerable to the environment at the moment, because in this state, he's in what we call a soft shell state, meaning that it is not a hardened crab shell like you think of. Instead, he is very, very soft and pliable, almost like a basic kind of cartilage to him. So it offers some protection, but certainly not what the shell does. So for a few days until his shell calcifies and hardens up again, he's at risk. Now we also have some other organisms that don't necessarily shed that exoskeleton, but certainly do have one in our snail here. Looking at a very strong exoskeleton associated with this. This is actually a cowrie or a marine snail. We see these a lot in ocean systems. And little tube feet moving them around on the bottom as we would expect with a mollusk. And this nice hard exoskeleton shell that he's going to use as protection and as a home. Different from your endoskeleton. Your endoskeleton we typically look at as being primarily hard with our bones, but we also have to think about all of the supporting elements. So we look at cartilage. Okay. We look at the attachment points for things like tendons, ligaments, lots of different types of structures to help support that skeleton. You don't have the only type of endoskeleton. We actually see endoskeleton in echinoderms as well. Echinoderms such as this sea urchin have this endoskeleton because what we're actually looking at as the skeleton are these hard plates. So the image on the right is just our sea urchin with all of his spines removed, and these hard plates offer a huge amount of protection for this organism. Now, you're much more used to seeing an endoskeleton like this. You actually aren't that different from a frog when we look at an endoskeleton. These structures here, the bone is kind of this cream color. The cartilage points are these white spots. So we see both the interaction of bone and cartilage associated with these endoskeletons that we're more used to.